On to question 5, and we have completed 1 to 4 already, so go check out the playlist. This is November 25, paper 2, TZ3, and HL, of course. We have considered the following group dataset. Find an estimate for the mean and the standard deviation. And so we have frequency, class. What we can do now is find the mid-interval value. And I'll show you 2 ways to do this. With your calculator, without the calculator, you need to understand what you're doing. So we have 17.5, right? We want the middle, 22.5. We have 27.5, 32.5, and 37.5. Next is our cumulative or frequency times our mid-interval value, right? And that helps us get a total sum so that we can find our mean. 31 times 17.5 is 542.5. So this is a by hand method that I don't encourage you guys to do, but in case you need to, you can. So I've calculated the values for you already, and then we'll move on to how to do that with the calculator. 1087.5, and then we find the sum of all of this, and that is 5747.5. And so our mean would be this sum, 47.5 divided by our total frequency. And what is that? The sum of frequency is equal to 31, 29 plus 46 plus 61 plus 42, 209. And so our mean is equal to this divided by 209, which is 5747.5 divided by 209. That is equal to 27.5. Now, the thing with these probability questions is you want to use your calculator because usually it's going to help with these subsequent questions like the standard deviation. You don't want to do that by hand because it is a calculator question and it's only 2 marks. So let's learn how to do that. So what I'm going to do is go to my statistics section, the tables, and I'm going to put in my values into list 1 and 2. List 1, I have 17.5. We're going to use our mid-interval values, so we still have to find that. 22.5, 27.5, then we have 32.5, and we have 37.5. Next is to put in our frequencies, and that is 31, 42, 61, 46, and 29. Now, what I have to do is use my 2 variable statistics, and what I get is, they literally give it to us. So all you have to say is using, you don't even have to mention this, stats table. The mean is equal to 27.5. And we're finding the mean of our frequency, right? I mean the mean y. So what we can actually say is y. And it's actually a 1 variable situation, but you have to go into your 1 variable table and go to the settings for 1 variable, and so we have 1 variable x list is equal to list 1, and we have 1 variable frequency, we have to make it equal to list 2. Then we get the same output as this 2 variable stats table, which is what we want. But either way it works out, I'm using 2 variables. but in this case, x is our y, and y is our frequency when using our calculator. So just understand what are you doing. And now I have to find the variance, sorry, the standard deviation. And so again, the standard deviation of y is equal to the standard deviation of x on our calculator, which is on calc is equal to our 7.07. Okay, it turns out I did do it wrong. What I do have to use is our one variable stats table, or two, we can use either, but I recommend one. And what you have to do is go to set and set, like I mentioned earlier, one variable frequency is equal to list 2, right? That is what we need. And so what I end up getting, if I do that, is 6.26374087. So do check the whole thing. And that is equal to 6.2623 SF. And that is our answer. So this is important, understanding how to use our calculator. And now we can do B. B, the data can be approximated by a normal distribution. Use this information and your mean and standard deviation found in part A to find an approximate value for the interquartile range correct to 2SF. So what is our interquartile range? That is Q3 minus Q1. That's in your data booklet. But now we are talking about normal distribution, so we need to use our normal distribution, standardized normal variable, right? And that is z is equal to x minus mean divided by our standard deviation. And we have all of that, so let's find our Q3. That's our x, Q3 is x, is equal to our, or let's say x 0.75, or x3 is equal to our z score 0.75, right? And times our standard deviation plus mu, right? I'm just making x the subject here. And then our Q1 is equal to x1 is equal to z 0.25. Now we're not working in 1, 2, 3, right? We're working with, and the reason we're using 0.75, 0.25, let's think about this. So the probability of z less than z, or let's say x less than z, is equal to 0.25, right? When we have, what is our graph? Our graph is this, and we have everything. We have a bell curved center here. This is our mean. This is negative 1 standard variation. Let me make this slightly, right? This is 1 standard variation, 2 standard variations, negative 2 standard variations, right? And so everything below this is 0.25, this is 0.25, and this should be 0.25, 0.25. And so we call this z-score 0.75, this z-score 0.25. That's our Q1. This is our Q3. Q3 Z 0.75. Okay. And so we can do this, right? So essentially what we have, where's our graph? What we're doing is adding this to our mean to get x. And an important equivalency we need to know is 0.25 is equal to negative z 0.75, right? And this is going to help us. And let's understand why. So what we have here is negative standard deviation or positive standard deviation. And so that's why we have a negative positive. And so it's approximately equal to negative 0.67, I believe, or 674. That's our z-score usually when we're talking about that. Sorry, this would be positive. This would be negative. And so what we need to do is use these two formulas and put them in here to find our interquartile range. And we have Q3 is z 0.75 standard variation plus mu minus z 0.25 standard variation, standard deviation plus mu, and then this would be minus. So all we have now is 0.75 standard deviation minus. Now how do we do that? We use this, right? Special equivalency. And what we understand is then this is just negative 0.7 z 0.75. So what we end up getting is 2z 0.75 standard deviation. And what we just discussed, we know this, right? 0.674, and I think it's a 5 after. So we just use everything we know to find that out. That is equal to 2 times 0.6745 times our standard deviation, which was 6.26. Use the stored value, right? And so now I'm going to calculate that. 6374087, right? And what I get is about let's just put this to 3SF 4 that becomes 4.5, right? I'm getting 449.7 449.786. That is equal to 8.45 3SF. Did they ask? Oh, two significant figures, so they want this to two significant figures. Then we keep it to 8.4, and that is perfect. Now, that is how to do it by hand. You guys want to do this by calculator? There's an easier way, but first you have to understand what you're doing by hand in case you get a paper 1 question about this. So let's do this by calculator. Let's use our graphical calculator. What I have now is choose distribution, and we have all our values, so we just choose distribution, normal distribution. So what we want to end up doing is using our is our normal inverse function. So for b, we want to use our let me our inverse normal, right? Function on our calculator. And so what I did is went to distribution. So number one, distribution. Let's say Casio FX CG50. This is for me. Distance, sorry, distribution, then norm for normal, and then 3, you go to inverse normal, and then 4, you change data to variable, not list, not equals to list, not list, and number 5, you do area is equal to 0.25, and then check for 0.75. And I have to input the values for standard deviation and mu from above, right? And so now all I had to do is put in the area 0.25. So what I found out is Q1 is equal to 23.275171. Q3 is equal to, let me check, 0.75. What I get is 31.724829. Now I find the difference. IQR is equal to Q3 minus Q1, which we already had up there. Yep, here. Which is, let me calculate that. Use my other calculator. 31.724829 minus 23.275171. And that gives me 8.449658. And so it's probably more accurate than this one. And all I have to do is 8.42 SF, right? And so this would be more accurate. So always try to use our calculator when it's paper 2, and then when it's paper 1. So let me label this. If paper 1, this is what we have to do. And if paper 2, this is if paper 2. Okay, so remember that, and I'll move on to question 6 now. We have, sorry, that took a lot of time, but I was just trying to explain these different concepts. It was only for 5 marks, but I think it's important. A lot of people struggle with this. And then question 6. Consider the infinite series. Find the exact value of sum to infinity. This is a geometric sequence, right? And so our A is equal to, when k is equal to 0, 53 over 1000. That's our U1 or A. And then our R is 1 over 100, right? So now all we have to do to find sum to infinity, which is less than 1, right? Less than mod 1. How would I write this? Our condition is that R has to be less than 1. And so all we have to do is 53 over 1000 divided by 1 minus R. And so I get 53, and they say exact value, so no calculator in this case. 99 over 100. 100 comes up, so we have that. And so what I get is 53 over 990. So that should be our answer for part A. Now we have to do part B. Use your answer from part A express 0.253, which is this repeating decimal, as a fraction such that the numerator and denominator have no common factors. Okay. So let's actually think about what our series here means, right? We have, so u1 is equal to 53 over 1000, which is 0.053, right? 1, 2, 3, yep, 0.053, and then we have, so let's rewrite this series, 0.053, then we have plus 0.00053, right? Divided by 100, and then we have plus 0.0000053, and then plus keeps going, and so essentially what we have is 535353 recurring, right? Which is essentially what we have here, but we have an extra 0.2. So what we need to do now is use what we've just learned. So we have 0.2 plus this series that sums to 53.990. And all we have to do is understand that that's 220 over 100, or let's say 20 over 2 over 10, plus 53 over 990, and 10 times 99. So 2 times 99, that's 198 over 990 plus 53, right? So always show your steps, and then what we have is 198 plus 53. We can do that by calculator. 53, that's 251 over 990, and let's see if that matches. Okay, they haven't given a show that, so this is our answer. In fact, the only step we need to show according to the mark scheme is this. And so that's perfect. Guys, on to the next one, question 7, and I'll cover that in the next video. So do drop a like and subscribe if this helped. I covered a lot of stuff here, so hopefully you guys didn't get too bored or confused there. And hopefully this helped you out. See you in the next one. Please drop a like and subscribe.